This video is designed to give you an idea how to function with negative exponents. First of all, remember that a negative exponent is just a definition, and here's the definition. Anything to the negative n, or to any negative power, simply means that it's 1 over that base to the positive power. So, for example, if you had 3 to the negative 2, this simply means 1 over 3 squared. Remember, this is not a negative number. Exponents are just counting for you how many of those factors from the base that you have. If it's a negative exponent, it's simply telling you that those factors, after canceling, for example, or some other activity, those factors wind up on the denominator and not on the numerator. So another example would be if you wanted to simplify a somewhat straightforward expression. Perhaps you had an to the negative 3 over n squared. You might look at this and say, oh, how do I simplify this? Well, you recognize that n to the negative 3, the formal way, can be replaced with 1 over n to the third. And of course, then you treat your a as a over 1, and you treat your n squared as n squared over 1. And once you simplify, you realize the top is just a over n cubed, and the bottom, of course, is n squared over 1. And applying the flip rule for division of fractions, you get times 1 over n squared, which gives you a over n to the fifth. So anytime you're faced with a negative exponent, you can, if you wish, simply replace it with its 1 over version and solve using your fraction flip rule skills from that point on. Another thing that you can do with negative exponents, you can understand that if you push it through its main dividing line, it will change signs. So theoretically, this n to the negative 5 would be n to the positive 5 on the denominator, and n to negative 8 that's on the denominator would be n to the 8th on the numerator. But we can also demonstrate that by using our clever 1 idea and recognizing that if we multiply the denominator by n to the 8th, the n to the negative 8th times n to the 8th will cancel each other out and give us 1. So this is all equal to 1, which means that if we multiply the numerator by the same thing, we've simply multiplied by 1, and now we've cleared the denominator of our negative exponents, and we can simplify this as n to the third following our exponent rule of adding exponents in this situation. You could also finish this problem by recognizing that the definition of n to the negative 5 is 1 over n to the fifth, which would be times n to the 8th over 1, which of course gives us n to the 8th over n to the fifth, which is n to the third when you're done canceling n's. On our final slide, we have a horrible, complicated stacked fraction of negative exponents and positive exponents and this mixture of horrible things. And at first, this is quite daunting looking. But you can realize, since the main dividing line is the widest one, that it's actually these two lumps, the numerator lump divided by the denominator lump. If you can pick apart each small piece, interpret it correctly using your exponent rules or your ability to use the definition of a negative exponent, or by clearing denominators under certain circumstances and then using your fraction skills to eliminate it in a stacked fraction process, this problem is not that hard. It's just taking your time and getting each detail right. So, this section right up here, if we interpret that correctly, is n over a quantity squared. The next section is a little more complicated and should be done off to the side, but you can find that really it's going to be 1 over an divided by a squared n to the third as a lump. It's divided by a squared n to the third, which is what the expression in the brackets comes out to be. Sorry, that's a squared. Doesn't seem to want to write. A squared. There we go. Then there's the main dividing line. Again, I'm just trying to keep each piece intact and do a little bit of a step each time. The section right here can be interpreted as 1 over a over n cubed all squared. And the denominator of this is going to be 1 over a over n, which you can apply the flip rule to. So that's this section right here. Now we have no more negative exponents, and it's simply a matter of sorting out your proper exponents and also fitting it into this page. I may transfer some amount that I get to the next page. But what we've got on the top then is going to be n squared over a squared over, and I'm going to use the flip rule, it's going to be 1 over a n times 1 over a squared n to the third. And this is all going to be over 1 over a squared over n to the sixth, and that's going to be over 1 over 1 times n over a, if we apply the flip rule there. What this will give us, if I can fit it all in, is going to be n squared over a squared over 1 over a to the third n to the fourth. That's a 3, n to the fourth. And on the denominator, what we're going to get is 1 over 1 times the flip of a squared over n squared. So that's going to give us a squared over n to the sixth, excuse me. So that's going to give us n to the sixth over a squared over n over a. Now what we have is a fraction over a fraction on the numerator and a fraction over a fraction on the denominator. So each of those can be done by using the flip rule. So on the top you're going to get n squared over a squared times the reciprocal of 1 over a cubed n to the fourth, which is going to be a cubed n to the fourth over 1. And this is all over n to the sixth over a squared times the reciprocal of n over a, which is a over n. We simplify both the top and the bottom. You're going to see that some things are going to cancel, and when you put that together, you should get n to the sixth times a on the numerator over 1. And I'm going to put that over 1 just because on the denominator we're going to still have a fraction. So that's going to be n to the sixth over a squared times a over n. A's are going to cancel, n's are going to cancel, and we're going to wind up with n to the fifth over a. If we apply the flip rule, what we're going to get is n to the sixth times a, or a n to the sixth, times the reciprocal of this, which is times a over n to the fifth. So all of that. And I'm going to give us an answer right up there, and I will fit it into this final screen. When you simplify this, you're going to have a squared on the numerator, and you're going to have 1n left on the numerator, and you have nothing left on the denominator. And there's your answer. Hopefully this will be some assistance to follow the steps as this moves across. Remember, each time I'm trying to be very careful about keeping my sections intact and then working my way through it. I'm sorry that the writing isn't so neat, but that's not my forte. Hope this helps.